Today we will be finding the volume of prisms and cylinders. To get an idea of volume, let's look at perimeter and area. Perimeter is one-dimensional. It's the length of the distance around an object. On the trapezoid, the sides have lengths 2.6, 2.3, 4.3, and 2.3. If we place each of those lengths in a straight line, here's my 2.6. Here is my 2.3. There is my 4.3. And there is my other 2.3. If we place them all in a straight line, what you can see is that we have one dimension, it's linear, and the length would be all of those numbers added together, or 2.3, or 2.6, 2.3, 4.3, and 2.3. And all added together, that comes to a grand total of 11.5 units. That's the concept of perimeter, the distance around an object, one-dimensional. When we go to area, what we're trying to find is how many squares we could actually fill an object with, or cover the space that an object takes up. Now, if this particular object happens to be 4 units long and 2 units wide, and we were to extend those and turn them into squares, what we would see is how many squares it would take to fill the object. And it's going to take a grand total of 4 squares to fill that object. Excuse me, 4 by 2, which is 8 square units. So that's 8 square units, or 8 units squared, in order to fill the object. When we're changing that from area to volume, now what we're going to be looking at is how many cubes we could fill that with. And each one of our cubes is going to be one layer. This particular prism is a rectangular prism, and it has a base that's 3 units long and 2 units wide, and the whole prism is 2 units tall. Now, if I take this and I pull this in, this is actually 2 cubic units, and you can see that it's the bottom layer of my rectangular prism. And since the bottom layer has length 3 and width 2, it's going to take 6 cubic units in order to fill it. So I have 6 cubic units in the bottom of that. Now, if there's 6 cubic units on the bottom layer, and I have 2 layers tall, so this was 3 by 2, that made 6 on the bottom layer, and it's 2 layers tall, then altogether what it's going to take to fill that is going to be 6 times 2, or 12 units cubed, or cubic unit. This gives us the actual formula for volume of any prism or cylinder. And that formula is volume equals BH. And in this case, B represents the area of whatever shape the base is. Now, that leads us to our next issue, which is the different type of skills we need. We have to be able to find the areas of regular polygons, and remember that's going to involve an apothem, perimeter. We may need to use the central angles. We may have to use SOHCAHTOA in order to get that information. Now, the first job to this is going to be to identify the shape of the base and apply the appropriate area formula. After we do that, we can get the big B. All we need is the height. That's the easy part. And then we just substitute our numbers into the formula. So on this example, our base happens to be a hexagon. And the length of each side of this hexagon is 2 centimeters. Now, this is taking us back a couple of lessons. The first thing to do to find the area of that base is to go to the center and draw in the radii and find the measure of that central angle. Since there would be 6 angles around this hexagon, 360 divided by 6 is 60 degrees up in the central angle portion. Now, We need the apothem, so that means we need to draw the perpendicular down to the side. And remember, when we do that, it cuts that 60-degree angle in half. So we're really looking at a triangle here. It's a nice right triangle that is 30 degrees in the top angle. We have our 90-degree angle, which means our other angle is 60 degrees. The particular piece of information we're looking for is the apothem. And I can figure out the length of this side at the base down here next to the 60-degree angle, because the whole side of my hexagon was 2 centimeters. I know this side is 1 centimeter. Now, I want to find the length of the apothem. So what I'm going to do is I'm going to use SOHCAHTOA. And because I'm using SOHCAHTOA, I want my variable to be in the numerator. The pieces I have are opposite and adjacent. So I'm going to say that the tangent of 60 equals the apothem over 1, or the apothem equals 1 times the tangent of 60. Now I can sub into the formula for the area of my base here, and in this case, base equals 1/2 times the apothem times the perimeter. So my formula, or my equation, is going to be base equals 1/2 times 1 tangent of 60. And then I have to multiply that by the perimeter. Well, there are 6 sides. Each side is 2 centimeters long. So in this case, P is 6 times 2. So that's 12 centimeters. Now, when I take that information and I multiply it all out, this is the result that I get. The area of my base is going to be approximately 10.4 centimeters squared. Now to get my volume, I have to take that and multiply it by the height. So my volume is going to be 10.4 centimeters squared times 5 centimeters. Excuse me, these were meters, not centimeters. Times 5 meters, and 10.4 times 5 is approximately 52 meters cubed. Because I was multiplying square meters by meters, I got meters to the 3rd power, or meters cubed. Now let's apply that same concept to the shape below. This one happens to be a rectangular prism, and you get to choose which side you want to be the base, which side you want to be the lateral faces. I'm going to choose the base to be the bottom and the top that you can see me shading in. So the dimensions of my base were 28 by 2, and because the base is a rectangle, all I have to do is multiply my dimensions together. So 2 centimeters times 28 centimeters is 56 square centimeters. Now the height of my object is 15 centimeters, so my volume is going to be 56 centimeters squared times 15 centimeters, or a lovely grand total of 840 centimeters cubed. We could either call that centimeters cubed or cubic centimeters. When applying the formula to a cylinder, it still is the same formula. The formula is still V equals area of the base times the height. It's just that because on a cylinder the base is always a circle, the formula for a circle is pi r squared. So usually when we refer to cylinders, we change the formula to say V equals pi r squared h. Just because we're substituting in pi r squared doesn't mean it's any different. It's still the area of the base times the height. On this cylinder, our base has a radius of 5, so it's pi times 5 squared, or 25 pi, and these were inches, so it's 25 pi inches squared. The height is 15 inches, So when we calculate our volume is going to be 25 pi inches squared times 15 inches, or I believe that should be 375 pi inches cubed. Now, if you decide to take that and round it to the nearest tenth, we're going to get the following answer, which is 1,178.1 cubic inches. Now remember, that is an approximate answer because it has been rounded to the nearest tenth. This concludes this evening's podcast.